Hello, hello. I'm Krishnavani. Now I want to explain uh, my science project. So here, just I want to, for the sake of completeness, I want to explain the phase one report also. So basically, my molecule name is 2R0LB out of PSF.PDB. So here, how I means generate all the SMID files out of the given PDB file is I applied VMD software to generate all the files. So let me show the files once. So here this is the PDB file uh, which I get from the instructor. So by applying VMD software, I get the PDB and the related auto PSF files also. So after that after that so I need to explain the assembly.NAMD files also and assembly.tcl file also. So just let me show that assembly.NAMD file once. So here this is the assembly.NAMD file. So you can see here this is the PSF file and the coordinates file is the PDB file, means which is generated from the VMD software. This is not the exact file which I get from the instructor. This is the file which is generated from the VMD software, and the output file name is DA underscore assembly. So here it is. And so here these all are the parameters. These parameters generally just define the structure of protein and the forces which are acting on the molecule, and like that. So here we can also see the time step which we put as 2. Here the time step 2 fs per step. So here there are also some, means here Langevin means, do you want to start the pressure or not. I just put off. So and there are also the DCD frequency which is 500, which I put. And the basic thing which everybody wants to know is I run the assembly.NAMD file up to 10,000 steps with 2000 picoseconds. So here, but what are the script means, how much velocity we have to apply on the protein. All those information will be in assembly.tcl. So let us see assembly.tcl also. And assembly.tcl also shares us the important things which basically here the protein is just we want to unfold the protein. The given protein is very folded, so we want to unfold the protein. For that, so one atom should be fixed. So this is the identity of which uh, this is the identity of the atom which is fixed. And here one end is fixed and another end should be moved. So one end is fixed and the other end is movable thing. And here we put the TCL frequency as 50, and the constraint points are the means, these points are written by, means I get these points from the PDB file, and after seeing the PDB file I get the endpoints of the atom. And just copy the constants. And the force constant, you already know that the force constant I put as 7.2. And here I put the velocity as 0.00002. And after running the simulation, the output file should be should go to somewhere. So I put DA SMD underscore TCL dot out as the output file. So and this is all the thing which we didn't is not useful to us. And you can see this is the molecule file. This is the remark original generated coordinate PDF file. This is not the original PDB generated file. This is the remark original generated coordinate PDF file. And this is the information of the molecule. And these are the points. So that's it. So now let's go back to the thing. So now uh, let me uh, mm, let me pass through this. So here what I did was I used SMD software for executing the file, and PSF file was obtained from the VMD software. It contains info on how to perform the simulation, which also tells about how force, fields, and directions. And I run the simulation for nearly 200 picoseconds. And now the PDB file tells about the protein, like its position in the X coordinate, Y coordinate, and Z coordinate. And the DCT file contains all information of all atoms, position, velocity of all frames is generated from the NEMD software. Whenever we put NEMD software, these all are the things which are generated. So so step by step output, step by step we can find how protein unfolds as after proceeding in forward direction. Means all the step by step things shown in the log file, and also in the DASMD and TCL.out, which I have shown in the smd.tcl file. And after that we can just screencast the thing video, how the protein unfolds. Here the parameters which I put is step size 2 femtoseconds, number of steps 10^6, total time to velocity 0.002 angstrom per second, spring constant 5.2. These things are the parameters which I put for phase 1. So let us see how the molecule is unfolding. So here is how the molecule. This is the atom which is fixed, and the complete thing, how the atom is unfolded. So you can see first the atom is folded, and now the atom is slowly being unfolded, and you can see there is a straight line which is having slow minimum jerks. So that is how the molecule is unfolding. So that's it from the simulation part.